Sorry, I had a phone call there. Um, so use a calculator to determine to 4 decimal places the coordinates of the point on the unit circle that corresponds to a rotation of 2 over 5 pi. So if I have the angle 2 over 5 pi, then if I'm looking for my x values, I have cosine 2 over 5 pi, and I have sine of 2 over 5 pi. So this has to be in radians, so we'll double check, make sure we're in radians. And I am, so that's good. I have to, I'm not looking for the angle, but I type in the ratio first, and I just use all of those. I have to make sure I'm using all those decimal places for this coordinate, and it wants the first 4 decimal places. So if I were to try to graph this, I would have to graph it at x equals 0.3090, and I would have to find my so 0.3090, that would be my x value corresponding to cosine 2 over 5 pi, and my my y value would be 2 pi over 5, but it would be the sine ratio, 0.9511. So here we see that my cosine of these angles, my cosine of this angle, and the sine of this angle is directly related to the x and y values of the coordinates on the unit circle. Example number 4, I have 2 points, I have P and Q, and these are the coordinates, and they're 2 points on the unit circle. If an object rotates counterclockwise from point P to point Q, through what angle has it rotated? I want my answer to be in radians and degrees. So let's just draw a picture of what is happening right here. So I have 1 point Q, which is at a negative x value and a positive y value. So it's going to be somewhere in quadrant number 2. If I look at what those values are, negative 1/2 and root 3 over 2. Well, negative 1/2 and root 3 over 2 is at 120 degrees, or 2 pi over 3 radians. So it's somewhere up here. All right. So this was point Q. And I have also point P, which has a positive x value and a negative y value. So it's somewhere in my 4th quadrant, so positive x, negative y. And this also corresponds to a point on my unit circle. So the square root of 2 over 2 is the x value, and the y value is negative square root 2 over 2. So that corresponds to 315 degrees, so somewhere down here. So that's point P. And I'm told that it rotates counterclockwise from point P to Q. So it goes in this direction here. And I want to know what the angle it rotated through. So what is this angle here? All right, so I know that P is equal to 315 degrees, and that is 7 pi over 4 radians. And point Q is 120 degrees, and that is 2 pi over 3 radians, or rads. Now, what is that rotation from P to Q? So from P to Q, how do I get there? So if I start here, how do I get all the way to Q? Now, if I think about what my reference angles are from here to here, here to here, and here to here, I can add up all my reference angles. So my reference angle of P and my reference angle of Q plus the reference angle, or the angle that they go through here, which would be 90 degrees. So it's going to be this 90 degrees plus this reference angle and the angle between here and here. And so let's see what we have. If I know I have 120 degrees from 90, I know this is going to be 30 degrees. I know that this is 90 degrees. And if I'm at 315 degrees, the difference between 360 here, and 315 degrees where this is at is 45 degrees. And so if I add up all these reference angles, and actually the only two that are the only one that is an actual reference angle is this angle here, 45 degrees. The other ones are not reference angle. They're small because they're not a small acute angle to my x-axis. But from P to Q, I'm going to have 45 degrees plus 90 degrees plus 30 degrees, which leaves me with 165 degrees. So this angle that it rotates through is 165 degrees. If I was talking about this angle in radians, well, I know that if I have 45 degrees, that is equal to pi over 4 radians, or pi over 4 radians, not degrees. And 90 degrees is pi over 2, and 30 degrees is pi over 6. So if I add up all of these, I have a common factor of 12, so times 3 times 6 and times 2. So I'd have 3 plus 6 is 9 plus 2 is 11 over 12 pi, which is the same thing as 165 degrees. Or we can convert it, it's a lot shorter I guess, is to convert this, and we just go 165 over 180, math fraction 11/12. Next, let's look at without using a graphing calculator, determine the exact value of log 2 cosine 7 pi over 4. All right, so what we're really looking for is, what this question is really testing is your recall of logs, but also that you know that this cosine 7 pi over 4 can also be written as log 2 of x, because cosine 7 pi over 4 is the same thing as, or it corresponds to an x value, an x coordinate, right? So if I know that cosine 7 pi over 4, if I look at a unit circle, is actually equal to log 2 of root 2 over 2, then this becomes something that's a little more, or a little easier to work with, right? Now I've eliminated working with my trig ratio. So root 2 over 2, we can rewrite it also as log 2 of 2 to the power of 1/2 divided by 2 to the power of 1. If I use my exponent laws, 2 to the 1/2 subtract 1 would leave me with 2 to the negative 1/2. So I'd have log 2 of 2 to the negative 1 over 2. And we can rewrite this as negative 1/2 log 2 of 2. And we know that log 2 of 2 is just equal to 1, and so that becomes negative 1/2. Let's see. I'm going to skip this example, and let's move on to turn methods to the unit circle using reference triangles. All right, now using reference triangle, I'm going to be giving you guys the unit circle as something you can refer to, just because I don't know if you're going, well, yeah, memorizing the unit circle is asking a little much, I think. And this chart, however, this is something that you could memorize, but if you have the unit circle in all honesty, you don't really need to memorize this either. But we're going to be using this chart for referring to these examples in the next, in filling out this chart. Okay, so if I'm looking at complete the work to determine the exact values of sine 210 degrees. So sine 210 degrees would rotate to this position here. That would be my terminal arm here. So rotation angle of 210 degrees, and then we have a reference angle of 30 degrees. In quadrant 3, the sine ratio is negative. All right, so in quadrant 3, the sine ratio is negative. If I have a reference angle of 30 degrees, and I'm looking for the sine ratio, if I refer to this chart, I have a reference angle of 30 degrees, my sine ratio is negative, but at 30 degrees, sine ratio is equal to 1/2, which is the y value, right? But if it's a negative sine ratio, that means this would be negative 1/2. If I look at this next example, cosine 5 pi over 3. Well, if we refer to our unit circle, 5 pi over 3 is right here at 300 degrees. So I'm looking at something that has a reference angle then of 60 degrees, which is the same thing as pi over 3. And it's also down here. And so I'm rotating my terminal arm to quadrant 4. The reference angle will be found right here, 60 degrees or pi over 3. So we're in quadrant 4, and if I'm looking for the cosine ratio here, then the cosine ratio is positive. Cosine 5 pi over 3. Well, cosine 5 pi over 3 has a reference angle of pi over 3, and if I look at where I have pi over 3 or 60 degrees, pi over 3, cosine is also 1/2, just like sine was 1/2 when I had 30 degrees, sine 30 degrees. So my reference angle was cosine pi over 3, and that was equal to 1/2, 1/2. In this part C, we're starting basically from scratch. I have negative 225 degrees, and so I'm rotating to negative 225 degrees. So if I go 90 in this direction plus 180 in this direction, not quite 270, I'm ending somewhere around here. My reference angle, however, so my reference angle is equal to 108 or 225 minus 180 degrees, which would be 45 degrees for a reference angle. So we end up in quadrant 2, and if I'm looking for tan, then I know that the ratio is negative in quadrant 2 for a tangent ratio. And so if I'm looking for tan negative 225 degrees, that's going to be equal to negative tan 45 degrees. And 45 degrees for a tan ratio, if I look at my chart, is equal to 1. And so tan negative 225 degrees is equal to negative 1. Lastly, let's look at we'll look at class example number 7 as the last example. Determine which of the following points lie on the unit circle. So remember, the definition of a unit circle is having a radius of 1, and when we have a radius of 1, we form our special triangles of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, all with a radius of 1. And so when we are forming, or when we're solving equations of our unit circle, we're trying to get them to equal the radius, which is equal to 1. So our x coordinate and our y coordinate have to add up to equal 1 when we take the Pythagorean theorem. So x squared plus y squared equals r squared, and it has to equal 1. Right? So the equation of a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. So determine which of the following points lie on the unit circle. I have 1/2 squared plus 1/2 squared. X squared plus y squared equals 1 over, square root of that would be 1 over 2. So 1 over 4 plus 1 over 4. And we would have square root of that would be, which would be 1/2. And that does not equal 1. So no, this does not lie in the unit circle. Well, how about this one? 16 over 65 squared plus a negative 63 over 65 squared. Let's see if this equals 1. 16 divided by 65 squared plus negative 63 and negative 63 divided by 65 squared equals 1. So yes, this is on the unit circle. And we would take the same approach for this question right here. And yeah, there you have it. When you're trying to solve for the actual equation, like in this example here, remember that this is your x value. You're solving, in this case, for your y value. Determine the value of y. And remember that it's going to be equal to 1. So that's going to be your second variable here.